All right, hey, thanks for watching this quick video going over half sheet homework 6.8. Make sure you watch the whole thing. I'm going to be just giving you a quick reminder on how to solve these. Perhaps if you had trouble, give you another quick reteach. So number one, 2e to the x equals 60. Now this is an exponential equation because x is in the exponent, and that means we want to try to isolate the heart of the problem, the e to the x. So if you want to isolate that, you got to do the dividing by 2 first. You always want to take care of those numbers that are on the outside. So we divide by 2, we get e to the x equals 30. Now, for the main step, you're going to slap both sides with an ln. An ln is a natural log, and it's basically a log that's going to cancel with e. Now, because it cancels with e, none of that is there anymore except for this x that came down. So basically, you just end up with x equaling the ln of 30. What's the ln of 30? Well, that's going to be a little calculator computation where you're going to use your ln button. Make sure that you know how to do that on your calculator. Here's the ln button, and you pop that in there. You get 3.40 to 2 decimal places. So x is 3.40. Now, number 2 is not an exponential equation, it's a log equation, obviously, because it starts with a log. Now, if you have an ln, you want to try to undo that. And because this ln is on the outside, I can kind of jump right in here and I can base both sides with an e. Now, when I base both sides with an e, it's going to cancel with the ln and leave us with just x plus 4. But x plus 4 equaling e to the 5th. What is e to the 5th? Another calculator computation. So make sure you know how to use your E button. Now that E button is this e to the x command, which is second ln. So you're going to hit second ln, and that's going to give you this e to the x command where you can just do e to the 5th power. Looks like it's 148.41, but you see x plus 4 equals 148.41. So when you subtract 4 from both sides, kind of like a little step that you got to do at the end, now we're going to end up with our actual x value. So it was a log equation. I'm going to base both sides with an e. Here's a log equation, but the problem is if I try to base both sides with an e right away, I'm breaking the rules of math. You see, you can't distribute an e to every one of the ln's. So instead, I got to use that concept where we condense the logs. Now, condensing logs that have a plus sign means that you're going to end up multiplying. But what are you going to multiply? You're going to multiply the 5 and the x. So we would write this as the ln of 5x. That's a little tricky, but that's called condensing. And again, when adding, you multiply. Now you can base both sides with an e, because now you have just one log that cancels. That leaves us with just the 5x equals e to the 1st power. E to the 1st power, well, I can calculate that on my calculator, but I'm going to go ahead and actually finish the problem because we can also divide both sides by 5, kind of make it a little bit quicker. So I'm going to end up taking e to the 1st power divided by 5. Again, I'm using my E button, which is the second ln, and that comes out after you divide by 5 to be 0.54. So I had to condense when there were multiple logs. This is another exponential equation. Exponential equations, x is in the exponent. You want to try to isolate. You want to isolate the heart of the problem. The heart of the problem is the e to the x part. But basically, I got to start by doing some inverse operations. I have to work on the outside of the equation. All right, when you add 7, of course, you get 21. Now, at this point, the e to the x is isolated. So I'm able to do the ln of both sides. Now, when I do the ln of both sides, it cancels, but my exponent is able to come down. So I get 2 minus 3x, well, equals the ln of 21. Now, the ln of 21, that's something that you're going to put on your calculator. Again, you can use that ln button, and it looks like that's equal to 304. which is good enough to 2 decimal places. So again, I get 304. And even though I have a decimal here, I can just finish solving this equation like you would solve any equation. You know, subtract 2, make sure you do that next. Of course, that's going to leave us with 104. And then you can divide by -3. So I have to kind of finish the problem with a couple of those extra steps at the end. But that's no problem. I'll end up with negative probably more like 0.35 when you round that. The last one, it's not a natural log equation, it's just kind of a generic log equation. It's a little bit of a review question. But again, what we see here is we see 2 logs being added together. And according to the rules of condensing, when you're adding, you multiply. What do you multiply? You're going to multiply the x and the x plus 2. That's a little tricky because what's x times x plus 2? Well, I'll probably end up doing the distributive property, but before I do that, I need to get rid of these logs. Remember that these logs are the general logs, so they assume to have a base 10. Since they're a base 10, I can base 10 both sides, and when I base 10 both sides, it causes those logs to cancel. If you do the distributive property, might as well do that now, we get x squared plus 2x equals 8, and what is this? Well, this is a quadratic equation. It's a quadratic equation that wishes it was equal to 0. So let's make it equal 0, and then you can actually finish solving it using quadratic methods like factoring that we did the first part of the year. So do I end up with 2 answers here? Well, it seems like I might, but it turns out that you're not able to have a negative number. You can't do the log of a negative number. And so if I'm really careful, I'm going to be able to cross that one out and just choose x equals 2. Now, I'm going to ask you to, as a little virtual assignment, to complete a few other equations that are similar to these, and you can go ahead and proceed with that on the Google form.